What was A slope, Sophia? Excellent, -5/2. So the only two that matched were which two? -2 and -2. So does anyone remember how we write it? AJ?
B to the two straight lines, C.
Very good. And that indicates B is parallel to C, okay? Why was A not parallel to either one of them? Did not have the same slope, okay? Its slope was 5/2, not 2, -2. We Gucci? What would be the perpendicular slope to -2? McCarvin?
I have a question about...
Okay, hold on. Austin? 1/2. Okay? McCarvin, what's up?
I was going to ask, how would you write the answer if it was like if all three were parallel?
Okay, so you would have to say B is parallel to C, A would be parallel to C, and B would be parallel to A. Okay? Because technically there's 3 lines of parallel. But this is not what we write for this scenario. Okay? Yes, Mia.
Did you get positive 1/2? Did you say 1/2 or 5?
No, the slopes are right here. So -2 and for perpendicular, you use the opposite reciprocal there.
Did you say 1/2 or 5?
Positive 1/2.
Wait, where do you
I'm talking about the opposite reciprocal of these two guys, not of the -5/2. For that one, it would be 2/5. Okay, we Gucci? All right, any other questions on the warm-up? Okay, you can turn your quizzes over. All right, so today what we're talking about is something called a scatter plot. How many people have heard the word scatter plot before? Okay, so a scatter plot, how I like to remember it, and it's a funny little saying, is I like to remember it as controlled chaos, okay? Controlled chaos, okay? Sometimes it's very controlled and your scatter plot leads you to believe that the equation is a line, and other times it's complete chaos and there's no line that represents the data, okay? So a scatter plot by graph that shows the relationship between two data sets. The two data sets are graphed as ordered pairs in a coordinate plane, and scatter plots can show trends in the data, okay? Keep what? Okay? All right, so when we're interpreting a scatter plot, okay? So they gave us a scatter plot in the first example, and we're asked some questions about this scatter plot, okay? Before we start to answer these questions, let me give you some background information. It says each of the dots or each of the points in our scatter plot represents a smoothie, okay? So the smoothie is identified by the number of calories and the number of grams of sugar, okay? So let's just for reference take a look at this point all the way in the top right corner. This smoothie has the most grams of sugar. Do you guys agree? Because it's furthest to the right. How many calories is this smoothie? 320. Do you guys see how this is working? A point on your graph represents a smoothie that has a certain number of calories and a certain number of grams of sugar. Do you guys see that? Now, there's how many smoothies that have 290 calories? There's 4 of them. Why are there 4? Someone explain that to me. Alfred? Yeah, how'd you know that there was 4 though? Excellent. Do you see the 4 dots at 290? That means that there's 4 different smoothies that are all 290 calories. How many smoothies are 270 calories? Just 1, because there's 1 dot there. Do you guys see that? Okay, so let's answer some questions related to these problems. So erase everything from your graph and let's go ahead and answer the questions. The first question, it says, how many calories are in the smoothie that contains 56 grams of sugar? Well, let's go to our graph, find 56 grams of sugar, and find which smoothie fits that description. Kyra? 270, okay? Because at 270, it's this point. This point is 56 grams of sugar. Bless you. Okay, so 270 calories. We're going to abbreviate calories with CAL. Alec, you with me? Okay. How many grams of sugar are in a smoothie that contains 320 calories? Mr. Salucci. Excellent. 70, but we need to put units here, people. 70 grams of sugar. What tends to happen to the number of calories as the number of grams of sugar increase? Oops. So as our sugar goes up, no, excuse me. Yeah, as our sugar goes up, what's happening to the number of calories? It's also going up, okay? So as the sugar goes up, calories also increase. Okay? Alec.
Have a sudden jump down.
Yeah. So did you guys hear what Alec asked? Why do some have a sudden drop down? So do you guys see like at 54 grams of sugar, there's a 260 calorie drink and there's also a 240 calorie drink, 290, excuse me. And then at 56, there's one at 270. Now, we're looking for trends, right? So look at all the dots as a whole. Do you guys see how it's generally moving up as we increase the number of sugar? It's not going to be exact because it is a scatter plot, okay? That's a really good question. Alex, does that make more sense?
Yeah.
Okay. How many calories are in this smoothie that contains 51 grams of sugar? Gabriel.
260 calories.
Bingo. 260 calories. We go to our graph, we find 51, that's the closest number to 50, and there is our point at 260 calories. Casey, you with me? Okay, so let's go ahead and check how many grams of sugar are in a smoothie that contains 250 calories. Nick?
70 grams of sugar.
70 grams of sugar? Try again. Fuxa?
0.
Nope. Sophia? 52. Do you guys agree that 250 is right here? How many grams of sugar? Go all the way down. It's right at 52. Okay, right in between 50 and 54. Why did that last one confuse us?
Wait,
Mia?
are we answering 320 or 350?
No, 250.
Oh.
Is yours say 320? Sorry, I crossed that one out. Cross that one out, put 250. Oh, my bad, Nick. You would be right if it was 320, okay? That was just a repeat question, so I changed it for us. How we doing? Does it make sense? Okay, now, let's talk about some definitions when we do have trends, okay? Definition is, there's 3 that you need to know. There's something called a positive correlation, a negative correlation, and no correlation, okay? When 2 things are related, such that as one increases, the other increases as well, we call that a positive correlation, okay? Now, it tends to look like a line, right? And as we move left to right, what's going on with this line? It's going up. What do we know about this guy's slope? Positive, right? So write that down, positive. Our slope, what am I writing? Our slope is positive. Now, a negative correlation says, as one variable increases, so as we move from left to right, as x increases, your y values are now decreasing. So, in other words, as we move left to right, our graph is going down. Do you guys see that? What kind of slope does this guy have? A negative slope. So write that your slope is negative. And then we get to no correlation. What's happening here? Alec?
0 or undefined slope.
So undefined slope would mean everything lies in a vertical line. When we have no correlation, there's no line that could go through that points, right? And approximate it. Do you guys agree with that? It's completely chaotic, okay? So we're going to write chaos. And you can't represent by a line.
So what would you
Okay? You cannot represent it as a line. There's no pattern here. Okay? Karen?
Like, what would you write down if like one of it came out?
I don't know what you're asking.
They gave us this. What would be the answer?
Okay, you're going to see some examples down below. Let's see if those make sense. Okay? Okay. So take a look. We're going to identify some different sets of data and we're going to compare them, okay, and see if they have a negative, a positive, or no correlation. Take a look at the first one. Your age and the vehicles you owned in the past. Your age and the vehicles you've owned in the past, okay? Is there any correlation here? No. So we're going to write no correlation. Why is there no correlation? It's all over the place, okay? It's a true scatter plot. Everything's scattered. Now, let's think about that. I know some 16-year-olds that have like 9 cars because they're rich, right? So does it really matter how old you are and the number of cars that you've owned? My grandfather owned 1 car his entire life. Yeah, crazy, right? So it has, like, there's no correlation with your age and the number of vehicles that you've owned, okay? All right. What about temperature and coat sales at a store? Negative, okay? Now let's think about this one. This one's a negative correlation. Why is it negative? Yeah, as we go left to right, it's going down. Now, let's say that the temperature is increasing. So as the temperature goes up, what's happening to the coat sales? They're going down. So as temperature increases, coat sales go down. Why would that happen? Christian? Nobody wants a coat when it's 90 degrees. Do you guys get that? So, but as temperature decreases, what happens to coat sales? They go up, okay? So it works in both directions, right? But as temperature increases, coat sales goes down. Anytime it's the inverse of each other, one's going up as the other one's going down, it's a negative correlation. Do we see that? And this is what our graph looks like. Questions? Okay. C. We are not given the graph. What do you think we have to do? Graph it ourselves, okay?
We don't have a graph.
The reason that I want you guys to graph this one is we're going to use something called a break in this graph, okay? Some of you have seen a break before, others have not, okay? So when we're graphing ourselves, I want you to label your axes. So the x-axis, which is this one down here, what should we label the x-axis based on what's in the table? Temperature, right? So we're going to label it temperature. And my y-axis should be labeled attendees, okay? Attendees. And it's in thousands, so let's put that in there. Okay. Now, we utilize something called a break when your lowest value is not close to 0, okay? Because you're not going to have any points between 0 and, like, for example, 60, okay? So look at the temperatures, right? What's the lowest temperature that we have for the x values? 68, right? So watch what we do for the temperature so that we can start at 68. We add, like, it almost looks like a crack in the graph. And we can start with whatever value we want. So this indicates we're not going to be looking at 0 to some value, and we're going to start at whatever number we want. What would you like to start with if our lowest value is 68? You want to start at 68? Sure, we can start at 68. And then we have to come up with something that we can count by, a units that we can go by, that'll include all the way up to the largest value, which is 92. You want to go by 12s, AJ? You want to go by 1s? I don't think they'll all fit. Let's go by 4s. I like 4s because that keeps everything even too. So what's 68 plus 4? 72. Then after 72? 76. After 76? 80, 84, 88, 92, and then we'll just do 96. That's perfect because that fills out our entire chart. Good pick, Austin. Okay? Now, attendees. What is our smallest amount of attendees? 1.7. What's our largest? 5.5. Is 1.7 close enough to 0 that we don't need a break? Yeah, I'd agree with that, okay? What do you want to count by so we can include 1.7 all the way to 5.5?
About one.
You want to count by ones?
Yeah.
That's fine, okay? So let's count by ones. So we'll start with 1, 2, 3, 4, 5, 6. Nothing goes above 5.5, so we can stop at 6. You guys Gucci? Questions on how I labeled my axes? Which axis is the only one that has a break in it? The x-axis, okay?
Wait, what do you mean a break?
Do you see that little squiggly? Okay, so normally, what comes after 0? 1, right? But we're starting where? At 68, okay? So you need to include a break, okay? All right. Yes, okay? So, now we have to fill in each of my points. How many points do I have from this table? There's 8 of them, okay? So we have to fill them in. So my first point is 82, comma, 4.5. So find 82. It's somewhere between 80 and 84, right in between them, and go to 4.5. There's my point. 1 down, 7 to go. 78, and then 4.0. 68, and then 1.7. So just higher than, just below 2, but more than halfway between 1 and 2. You guys see that for 1.7? Okay. 87, so just before 88, and then 5.5. 75, and then 2.9, so just below 3. 71, and 2.9. Wait, I did that wrong. It was 75 and 3.8. There we go. And then 71 and then 2.9, just below 3. And then 92 and 4.7. And then 84 is at 5.3. Okay. Does yours look similar to mine? If not, check your graphing, how you are putting your coordinates in, okay? What does this look like in terms of its correlation? Positive correlation, okay? Why? It goes up. All right, once you're done with this, turn these notes in. And guys, since we did not finish the notes today, I'm extending your homework. 4.4 will not be due on Monday, but it'll be due on Tuesday, okay? Now, you have enough information. So, you guys, we graphed all the points, correct? Does this one have a positive, negative, or no correlation? Positive, okay? Write that down. So it's a positive correlation. Hey, why are we talking? Now, let's think about it. What scenario would this happen? What scenario would an increase in temperature lead to more people attending whatever it is? What scenarios exist where an increase in temperature increases the number of people going there, yeah? The beach or the pool is perfect. What else? Let's think of at least 3 examples. So the beach or the pool is correct. That's one example. What else? Yep. An ice rink? Well, an ice rink, if it's too hot, people aren't going to go there. So that would have a negative correlation, right? Because wouldn't the ice melt if it was too hot? Unless it's an indoor one. Yeah. Ah, more people go on vacation when it's warm outside. That's a good one. Okay, what else? One more. Come on, think. Yeah.
Fish going to the park.
Yeah, to the park, okay? Like, especially in like a cold state or like a cold city like New York, people do not go to the park when it's freezing cold out, okay? So more people attend the park, especially when it gets warmer out. Does that make sense, guys? Okay, so this has a positive correlation because as we increase the temperature, more people attended, okay? What about the stopping distance of an automobile? What kind of correlation goes on here? This one's positive. Why?
Because it goes up.
It's going up, okay? Positive correlation. And that makes sense, right? The faster you go, right? If your speed increases, it's going to take you a larger distance to stop. Do you guys agree? Like if you're going really slow, you can stop on a dime, right? If you're going like less than 20, you can stop immediately. But if you're going 60, it's going to take you more space to stop. Do you guys agree? That's why they always tell you, like on the highway, you have to keep your distance from the person in front of you. Because if they stop really fast, you're not going to have time to stop yourself. Does that make sense? Okay. What about your birth month and the number of hours you sleep per day? No correlation. Why would there be no correlation there?
Because the month that you're breaking it depends on how much you sleep.
Yeah. If you're an Aries, does that mean you automatically get 8 hours of sleep? No, it doesn't matter if you're a Taurus either, okay? So your astrological sign, what month you were born in, does not determine how much you sleep. Do you guys understand that? So when those two variables have nothing to do with each other, that's where it leads to no correlation. Does that make sense? What about like if I compared your height with your GPA? Do you think those two would have a correlation? No, right? Because those have nothing to do with each other. What about if I said the number of hours you studied per night and your GPA? Those would have a correlation. Positive, negative? Positive, because the more you studied, do you agree your GPA would be higher? Is we're going to use lines of fit to model data, okay? So we're going to put a bunch of dots on our graph, and then we're going to model that graph using a line of best fit, okay? So go ahead and jump to example 3, where it's comparing, the table shows the weekly sales of a DVD and the number of weeks since its release. Write an equation that models the DVD sales as a function of the number of weeks since its release, and interpret the slope and the y-intercept of the lines of fit. Before we graph, guys, let's interpret what's going on, okay? So when a DVD is released, like the first week, are the sales going to be high or are they going to be low? You think they're going to be low?
No.
Well, hi.
Have you ever seen the commercials for like, oh, out on DVD on this date, right?
Yeah.
Or out released to your home on this date? Most people buy it right away. Do you guys agree? Because they want that DVD. But as the weeks go on, what happens to the sales of that DVD? It goes down. So what kind of correlation do we have here? Negative. Because as the weeks go on, the sales go down, okay? So our graph, you guys agree, is going to look something like this, right? Okay, let's make sure that that happens as we do this problem. So let's go ahead and plot first. What's going to be my x-axis? The weeks, okay? You guys agree? What should I count by on the x-axis? By ones, right? So first week, second week, third week, fourth week, fifth. How many does it go up to?
8.
It goes all the way up to 8. So let's go count up to 8. You guys with me?
Yes.
Okay. What's my y-axis going to be? The sales, okay? Now, I need, what should I count by to have all the sales in there? Gabriel?
2s.
By 2. So go 2, 4, 6, 8, 10, 12, 14, 16, 18, and 20. Because what's the largest number of sales? 19, right? And it's in millions. So $19 million. We'll just put a dollar sign here so we know that it's in dollars. Okay, so what do I do once I've created my axes? Yeah, you plot all the points. So find the first week. In the first week, how much did we sell? 19. So 19 would go where? Between 18 and 20. Perfect. What about the second week? How many did we sell? 15? So between 14 and 16. What about the third week? 13. Fourth week? 12? The fourth week was 12? Was 11? The fifth week? 6th? 7th? What happened on the 7th week? There were 7? And the 8th week, the last week? 5. Does this support what we said originally? Why? This has a negative correlation. How do you know?
Because left to right is going down.
Good. From left to right, it's going down. Write that down. It has a negative correlation. In other words, when we're finding the slope of the line that approximates these data points, that slope is going to be what? Negative, okay? Make sure you make that connection. You guys agree that a line going through these points would be negative? Okay. Now, what we're learning today is we're going to figure out, okay, how do we get a line that approximates this data, okay? Now, listen carefully. You must pick 2 points from your data, okay? Now, your 2 points may be different than your neighbor's 2 points, okay? But pick 2 points that if you drew a line through them, it would be very close to all of the data points, okay? I'm going to pick 2, 15, and I'm going to pick 5, 10. Let's draw a line through those 2 points.
Can it be any 2 points?
Now, this line, do you guys agree it's very close to all of the data points? So it is a good line. Now, write down the 2 points that you picked. You can pick the same ones or you can pick different ones. I picked 2, 15, and I picked 5, 10. You guys with me? Did anyone pick 2 different points? Or are you guys all using the same points? Okay, that's fine. Now, I need to write an equation of this line because this is the line that approximates all of the data. Do you guys agree? That line is very close to all of my data points. How do I find the equation of this line? What do I need? You need the slope, okay? How do I find the slope? Rise over run, or y2 minus y1 over x2 minus x1. Does it matter which way you do it? No, okay? I'm going to use the formula because I have 2 points. Do you guys agree? And those 2 points were 2, 15 and 5, 10. So x1, y1, x2, and y2. When I plug them in, let's see what I get. I should get 10 minus what? 15 over 5 minus 2. What's 10 minus 15? Negative 5. And 5 minus 2? 3. So negative 5 over 3. Does it simplify? No. Originally, I said my slope of this line should be what? Is my slope negative? I'm a happy person, okay? Because what I just found matches what I had on the graph. Are you guys with me? A little bit? So we found the slope, and we have 2 points. What should I do next? Because I have to write an equation that represents this data. Caitlin? Good. Find your y-intercept. Now, are any of my points the y-intercept? No. So can I use slope-intercept form? No. What do I have to use instead, David? Point slope form. Who remembers point slope form? Alec?
Y minus 1 equals m times x minus x1.
Let's go. Very good. Yeah.
Why did you choose like 5, 10 instead of just the first and second point? Like,
Why didn't I pick the first and second point? Alec, you can pick the first and second point if you want. But look, if I pick those first 2 points, right? Which of these lines is a better approximation of my graph? The black line or the red line? You think the red line's a better approximation? The black, right? Why is the black better, guys? Why is the black line better?
it touches more points.
It's closer to the points. Do you guys see that? If the red line is further away from the points, it's not a good approximation of your line. Do you guys agree? You're going to get more error. Like, are there any points close to this line down here? No, but look at the red one. I mean, look at all the blue points compared to the black line. They're all super close. Do you guys see that? So you could have picked 2 different points, but as far as picking the first 2 points, I would not pick those because those are not a good representation of the graph.
119 and 85, are those like good points?
119 and 85, so going between these two. Yeah, that's a better line. That's very close, okay? Now, your line may be a little bit different than mine, okay? This is up to interpretation, but I would not pick the first two, okay? All right, so what do I do from here? I know I need to use point slope form. What do I do from here? Sophia? Plug it in, okay? It's going to be y minus, what was y1? 15 equals, what's my m? Negative 5 over 3. And then x minus, what's x1? 2. What do I do? David?
I have to put it until y equals 10x.
Good, because I don't know my y-intercept now, so I have to find it out. How do I find the y-intercept?
Yeah, 15.
Sophia? Good. Change this into y equals mx plus b. You first have to distribute the negative 5 over 3. I get y minus 15 equals negative 5 over 3x. I love how good we're getting at this, okay? What's that second one going to be, though? Positive 10 over 3. Okay? Yes?
I just want to say, I got different slope when I did the first and second points.
That's fine. Okay? You are going to get a different line. Because when I drew that line, do you agree, Alec, your line looks different than mine? So you should get a different slope and you should get a different equation. Okay? Now, Alec, is yours wrong and mine right? No. Okay? There's more than one answer here. Okay? All right. So if we move on, what do I do after this? Add 15 to both sides. So I'm going to get y equals negative 5 over 3x plus 10 over 3 plus 15. What do I still need to do? Natalie?
You still need to add the 15 to the 10 over 3 by making 15 and 15 over 1.
Good.
And then you add them together to get 25. And then the 3 plus the 1 is...
Did you guys hear what Natalie did? She added the 10 over 3 and the 15 over 1. So I'm glad that you said this. And you got 25 over 4
3.
over 3.
Oh.
What did Natalie forget to do?
Make a common denominator.
You have to have a common denominator before you can add fractions. So 15 over 1, we're going to change it to what?
45 over 3.
Good. We're going to multiply both the top and the bottom by 3. The numerator and the denominator. So we have y equals negative 5 over 3x plus 10 over 3 plus, what'd you say, Karen? 45 over 3. That's a big difference than 25 over 3, okay? What's 10 plus 45? 55. So y equals negative 5 over 3x plus 55 over 3. And now I have my slope and my y-intercept. What's my y-intercept?
55.
And 55 over 3. And my slope? Negative 5 over 3. All right, guys, questions on this one? Yeah, Alfred. The 3's, oh, good question, okay? So, did you guys hear Alfred's question? He asked, wouldn't this be 55 over 6, okay? Now, when we find a common denominator, we do not add the denominators together. You guys got that? You're going to keep the same denominator, but you do add the numerators, right?
Yeah.
So it turns into 55 over 3. Mia?
Wouldn't you, like, if you were to pick it 2 different points, would you get a different answer?
Yes. Okay? Now, that different answer is not wrong. Okay? It all depends on the points that you
So
picked.
when you grade, like, you can have to...
This question for me grading is very difficult because I have to grade based on the points that you picked. Okay? Yes.
Wait, which 2 points did you pick?
I picked 2, 15 and 5, 10.
I got 2 different points. I picked 2 different points, but I still got the same slope.
You got the same slope, but a different y-intercept or the same y-intercept?
Same y-intercept.
That's impressive. Did you guys hear that? So Christian picked 2 different points. Which points did you pick?
8, 5.
Wow. Cool. Very cool. Very cool. So your line should look really similar to actually it should be the exact same line as mine. Very cool. Very cool.
Wait, what happened?
So Christian picked 2 different points and got the exact same equation. Okay? Now, Alec, who potentially wanted to pick these 2, right? He's going to get a different equation. Do you guys agree? Why would Alec get a different equation? The line's completely different. Do you guys see that? So Alec's slope would be different as well. Okay, any questions on this guy? All right, what I want you to do is there's a